Now we talk about the type of chemical bond. There are different types of chemical bonds which can be formed. Two of them we have seen: ionic bond, covalent bond. Hydrogen bond we know, which is bond which is formed by the sharing of electron. A bond which is formed by the highly electronegative atom with the hydrogen. Okay, and polar bonds which are having charge separation. Okay, so when substances participate in chemical bonding and yield compounds, the stability of the resulting compound can be gauged by the type of chemical bond it contains. Okay, so the stability resulting compound can be seen. Okay, there are four types of chemical bonds between the strength and the properties. We know that covalent bond is the strongest bond. Okay, so these types of bonds as chemical bonding are formed by the loss or gain or sharing of electrons between two atoms or molecules. Like here in sodium chloride, ionic bonding can be seen. The outermost electron in the sodium is giving its electron over here. This was the excess of electron which was given to the fluoride. Now it was having 2, 4, 6, 8, and 2, 8 is its fluorine is having the stable state configuration. Sodium and fluoride both are having their stable state configuration. Okay. So it's the type of chemical bonding which involves the transfer of electron from one atom or molecule to another. Okay. This one atom of sodium is giving its this electron to fluorine so as to form the stable state configuration. Okay, here. Here an atom loses an electron which in turn gained by another atom. When such an electron when such an electron transfer takes place, one of the atom develops a negative charge, now called the anion. Jo leta hai, the one which takes is called as the anion, and the one which gives is called as the cation. So it is having the positive charge. Okay. The another atom develops a positive charge is called as the cation. The ionic bond gains strength from the difference in the charge between the two atoms. The more difference in the charge, the more stronger the ionic bond is. Okay. The greater the charge disparity between the cation and the anion, the stronger is the ionic bond. Now covalent bonding. Covalent bond indicates the bond which is formed by the sharing of electrons. Okay, now there is no gain or loss of electrons as was there with the ionic bonding. Compounds that contain carbon, also called as organic compounds, majorly commonly exhibit this type of chemical bond. Means covalent bonding is exhibited by organic compounds. The pair of electrons which are shared by two atoms now extend around a nuclei of atoms, leading to the creation of a molecule. Okay, so what is happening in the covalent bond? This was one nucleus having the positive charge. Two atoms approach each other. Electron cloud, which is negative in charge. So negative charge will repel each other, and positive charge will repel each other. But unlike charges will attract each other. So nucleus is positively charged. So what is happening? If carbon is having uh, 3 electrons and they want to form the bond, then what they will do? This bond will be shared, and uh, covalent bond is formed. Okay. The pair of electrons which are shared, this is the pair of electrons which is shared by two atoms now extend around the nuclei of atom, leading to the creation of a molecule. Now this is my ethane molecule. Okay, valencies of hydrogen are satisfied. Now polar covalent bond. Polarity, we know, if we talk about water molecule, then H positive and OH negatives makes it polar. Charge should be there. Okay. So covalent bonds can either be polar or non-polar in nature. In polar covalent chemical bonding, electrons are shared usually, since the more electron and negative atom pulls the electron pair closer to itself and away from less electronegative atom. Water is a very good example. Oxygen is more electronegative, so it is pulling that H positive, and thus uh, this is due to the electronegativity difference. And this water molecule is formed by the hydrogen bonding, which can be intramolecular or intermolecular. Intermolecular is between two atoms, and intramolecular is within the water molecule. Like if my this in the water molecule. Water is an example of such polar molecule. I am telling you the how to form inter and intramolecular hydrogen bonding that we will see in the hydrogen bonding type. So this is due to the electronegativity difference, okay, between the atoms. Now, a difference in charge arises in different areas of atoms due to uneven spacing of electrons between the atoms. Okay, so charge difference is there due to uneven spacing of electrons. Okay, one end of the molecule tend to be partial positively charged, another end to be partially negative charged. Okay, so now hydrogen bonding H2O. This is what the intramolecular within the molecule, and then what will happen? This is intermolecular. Okay, so this was my oxygen, more electronegative element. And these are my hydrogen. So this was the one molecule, and when it is forming this hydrogen bond, it is intra, and between two molecules, it is intra. Okay, it is inter. Hydrogen bond formed between hydrogen and a more electronegative atom or a group. Okay, so compared to ionic and covalent bonding, hydrogen bonding is weaker form of chemical bonding. Okay, hydrogen bonding is the most weakest, like covalent bond, then ionic bond, and then hydrogen. It is the weakest and it is the strongest. Wherein the hydrogen develops a partial positive charge. Okay, here the hydrogen develops the partial positive charge and oxygen has the partial negative charge because it is the more electronegative element. This implies that the electrons are pulled closer to more electronegative oxygen atom. Okay, so the electrons are pulled because it is getting a partial positive charge means it is donating, and oxygen is getting a negative charge means it is withdrawing or taking. This creates a tendency for the hydrogen to be attracted towards the negative charge of any neighboring atom. So, like hydrogen gets a partial positive charge, and this makes it to donate easily and being attracted towards the negative charge. This type of chemical bonding is called as hydrogen bond and is responsible for many of the properties exhibited by water. Okay, so this type of chemical bonding is called as hydrogen bonding, when hydrogen is having a partial positive charge and it donates its electrons to the positive charge to the neighboring atom, which is more electronegative. And this property is tend to be shown by the water molecule. Then hydrogen bond can be intermolecular and intramolecular within the molecule or between two molecules. This is between and this is within. Okay. Then hydrogen bond formed between hydrogen and a more electronegative atom or a group. Then what is ionic bond? Ionic bond, we have seen that it is the electronegative interaction between the positive and negative charge species due to the electrovalent or ionic bond. Okay. This is also called as electrovalent. Why electrovalent? Because electron valency in the polarizing power helps a lot in this. Okay, so the positivity or negatively charged ions are aggregated in an order arrangement called as the crystal lattice, which is stabilized by the energy called as lattice enthalpy. Energy is known as enthalpy, and in the crystal lattice, if it is arranged, then it is called as energy, which is lattice energy or lattice enthalpy. Okay, so the low ionization energy of the atom forming the cation should have a low ionization energy, high electron gain enthalpy of the anion. Anion should gain the electrons, okay, and cation should have the low ionization energy. High negative lattice energy enthalpy or energy of the crystal form, and generally the ionic bond is formed between a metal cation and a non-metal anion because Metals have the tendency to donate and non-metals have the tendency to withdraw or to receive. Okay. So now comes the writing of Lewis structure. That how we write Lewis structure. Okay. So the following steps are adopted to writing Lewis dot structure or Lewis structures. First, calculate the number of electrons required for drawing the structure by adding the valence electrons to the combining atom. For example, in methane, carbon and C hydrogen 4 molecules, there are total 8 valence electrons. How? Because carbon is having a valency of 4 and hydrogen, each hydrogen, single hydrogen, 4 molecules of hydrogen, if they are there, then 4 electrons will be there. 1, 2, 3 and 4. And for hydrogen, 1, 2, 3 and 4. So total of 2, 4, 6 and 8 electrons are there in methane molecule. Okay. Then each negative charge for anion, we add an electron to the valence electron, and for each positive charge, for cation, we subtract one electron. Okay, for cation, we subtract one electron from the valence electron. Using the, like if I am having Na positive, this was the positive charge, so I will decrease. Na positive means 2, 8, 1 was there initially in Na, which was 11. Now in Na positive, it will be 2, 8. I will decrease that minus 1. Okay, I will decrease the minus 1. I will subtract this minus 1. So this will be 2, 8, which is the stable state configuration. Okay. In case of Cl and Cl negative, we will talk about. So Cl is having 2, 8, 7. But in Cl negative, I will add 1. So it will be 2, 8, 8. In case of negative, I have to add 1. In case of a positive, I have to subtract 1. Using the chemical symbol of the combining atom and constructing a skeletal structure of the compound, divide the total number of electrons as bonding shared pair between the atoms in proportion to total bonds. Okay. So how I am going to divide the total number of electrons? I will divide the bonding shared pair of electrons between atom in proportion to total bonds. How many atoms? Like in methane here, 4 bonds were there. So in the proportion, I have to equally divide this 2 electrons to each CH bond. Okay. The central position in the molecule is occupied by least electronegative atom. Okay. The central position is occupied by the least electronegative atom. Hydrogen and fluorine generally occupy the terminal position. Okay, terminal means sidewise position is occupied by hydrogen and fluorine. After distributing the shared pair of electrons for single bonds, the remaining electron pairs are used for multiple bonds. Okay, like after distributing the shared pair of electrons for single bonds, shared pair of electrons, like if I am having the CH in the methane molecule, these shared pair of electrons are there. I have distributed them. Then in the single bond, then the remaining electrons pair are used for multiple bonds or for lone pairs for giving double bond, triple bond, lone pair, free radical reactions such as like that, etc. The basic requirement is that each bonded atom gets an octet of electrons. Okay, so they should have their octet completely filled. Okay, 2, 8, 8, 18 like this. So if I have to write the Lewis structure formula for carbon monoxide is like I know carbon is having 4 electrons, so 1s to 2s2. Okay, and in case of oxygen atom, it will be 1s to 2s to 2p4 because 6 is the atomic number. It will be 1s to 2s to 2p2. So 2s to 2p2 I am taking here. Valency is 4. Oxygen 8 atomic number. Valency will be 2, 6. 2s to 2p. 2, 2p4 will be there. Okay. In oxygen, 6 is valency, 2s to 2p4. So this is giving you 4 plus 6, which is equals to 10. Here, carbon is having a valency of 4. Oxygen is having a valency of 6. 6 plus 4 is giving you 10. Okay. So 4 carbon plus 6 oxygen valence electrons give you 10. Then skeletal structure of carbon monoxide is it's a planar structure. It is written over here like this. Drawing a single bond between carbon monoxide, completing octet on oxygen. The remaining 2 electrons are lone pair on carbon. This single, like oxygen was, the remaining 2 electrons are the lone pair on carbon. Okay, so like this, I will draw the structure of carbon monoxide. This does not complete the octet of carbon, and hence we need to have a triple bond. Okay. Now 1, 2, 3, 4, 5. 1, 2, 3. So carbon monoxide is having a structure like this: C triple bond O. And what is there? Like if I know that carbon is making a bond of 1, 2, and 3, so this does not complete the octet of carbon. If I am writing a single bond between carbon and oxygen and completing octet on oxygen, the remaining two electrons will be lone pair on carbon. Okay. So this does not complete the octet of carbon, and hence we have a triple here. Now 1, 2, 3, 4, 5, 6, 7, and 8. This is completed. 6 is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is what actually the structure of carbon monoxide is. They have shared 6 pair of electrons, 6 electrons. 3 pair of electrons are 6 electrons. 6 electrons has been shared, and carbon was having now how much electrons? 2 electrons are there with the carbon. Carbon has just given 3 electrons, okay, of 2s2 and 2p4, 2p2, and oxygen has made the bond by sharing of electrons of 2s2, 1s2, 2s2, 2p4, 4 electrons. So like this carbon monoxide structure is formed by forming a triple bonded system with 6 electrons which are shared, and carbon is having a 1 lone pair of electron and oxygen is having 2 lone pair of electrons. Okay. Now what exactly formal charge is? Formal charge is any charge on any moiety of the atoms. So if we talk about NaCl, Na positive and Cl negative, these are the very good example of formal charge. Na positive is having 281 configuration, which is the stable state configuration after giving the +1 charge. So 2,8 is actually the stable state configuration in sodium. So formal charge is based on pure covalent view, okay, of bonding. Like if I take the example of ozone molecule, okay, ozone is O3. So how oxygen will form the bond? Oxygen we know 8 is the atomic number, 2 comma 6 is its valence electron. So if oxygen will form the bond 2 comma 4, so 1, 2, 3, 4, 5, 6, 7, and 8. This is having 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. This is also having 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. It is also having 8 electrons. And this is how the structure of ozone is. Okay. O double bond O and single bond O with the 3 lone pairs on this oxygen, 2 lone pairs on this oxygen, and 1 lone pair on this oxygen. This is the structure of ozone looks like. Okay. So there is a formula to calculate the formal charge. V minus L minus 1 by 2 S. So we know that the valence shell electrons in the oxygen in ozone molecule is 6 minus lone pair of electrons. Lone pair of electrons or how much oxygen atoms have been numbered. Okay. So we know that the lone pair of electrons are maximum the total number of non-bonding lone pair of electrons is L. So total number of non-bonding electrons are like this lone pair is taking part in this lone pair, 3 lone pairs are there, this lone pair and this lone pair. So these lone pairs are not taking part. And how many lone pairs are taking part? Actually, so oxygen, this lone pair and this lone pair is taking part. So only 2 lone pairs are taking part in the configuration or the covalent bonding formation. So we have to take here the lone pairs which are taking part in the electron covalent character. Okay, covalent bond formation. Okay, and 1 by 2s. where S is the total number of bonding or shared electrons. Okay. Non-bonding or lone pair electrons and total number of bonding or shared pair of electrons are how many electrons? 1, 2, 3, 4, 5, 6. These are the bonding electrons. Okay. Bonding electrons are 6 electrons. Okay. So this will be 3 minus 6 minus 2 4 minus 3 is 1. Okay. So plus 1 is what actually the formal charge on ozone molecule is. Okay. Okay. So this is what actually the formal charge. So in the next class, we will continue with the covalent bonding characteristics and different types of covalent bonds which are present. Okay.